Okay. The next thing that we want to cover today is how do we find the sum of the arithmetic sequence 1, 3, 5, 7, 9, counting up by twos all the way up until we get to 27. Sum of all these terms. Okay, and we're trying to find the sum. Now the partial sum of an arithmetic series is the following equation. So we know that we can say S for sum is equal to n over 2 times I'm going to use the other equation that they have. Okay, it's n over 2 times the first term, a1 plus an. That's the first term. And that's the last term. Okay, now this is a very special equation because this will always work out. But okay, we know the first term. Let's just call our first term A. Whoops, I need to put my glasses on because I wrote last as the first and first as the last. Uh-oh. That's not good. So that's first. And this is the last term. Yep. Now, let's list out what do we know about our terms. So we know that our first term, a1 is equal to 1. Our last term, in this case, we can clearly see that it's 27, but it's not always going to be the case. So to calculate the last term for an arithmetic series is, well, the key thing about an arithmetic series or sequence is that like you're always adding by the same number every time. In this case, it's plus 2, plus 2, plus 2. So that is our increase each time. That's typically represented by the variable d. So increase each time. D is equal to 2 in this case. And the last term, the nth term, because we need to know like n, which is like which term it is. Last term is an. That's equal to the first term, a1, plus n, which is like how many terms there are. Is it n minus 1? I think it's n minus 1, because like the second term you're only increasing by 1. I think it's n minus 1. Yep, they have n minus 1 multiplied by the increase every time. So the second term, n is equal to 2. 2 minus 1 is 1, so it's just a plus the increase. So it'd be like the increase is 2. So yep. And if you just try like the fourth term, n equals 4. That's n minus 1. 3 times 2 plus the first term. Yep, it makes sense. That would be the value of the last term. And we know that the last term number here for 27 is last term value is equal to a of n, which is equal to a1 plus, or it's literally written just here, but to sub in the a1 and the d values, we can solve for n. Because like let's say if that term was like 200,001, it might be difficult to like count them individually. We can math it out. It'll be a lot easier. So a1 is 1 plus n minus 1. We don't know that yet. We're trying to solve for n. And we know that d is 2. Okay, so 27 minus 1, all of that times 1 over 2 is equal to n minus 1. Okay, so that's 1/2 of, so 27 minus 1, that's 26, and divide that by 2, 13. 13 equals n minus 1, which means that 14 is equal to n. Okay, that's the first thing of interest that we need. Our last term, a of n, is 27. We know that. That's something interesting that we should keep track of. We know that d is equal to 2, and we know what the first term is. Okay, actually, we only need, to use this equation, another way you could write the equation, if you don't actually know what the last term is like this. N over 2. You're always pretty much going to need to know what the first term is. So a1 plus, well, let's sub out the last term, an, with what it's equal to here. So that's, let me just get a little bit more space. Un peu plus d'espace, oui, oui. So that would be a1 plus n minus 1 d, which is equal to n over 2. Well, we can just remove the brackets. So it's 2 a's, 2 a1s, plus n minus 1 times d. So if you don't know directly what the last term in that you need to consider is, like if it just says like find the sum of the series from the first term all the way to the 25th term, you don't actually need to find out directly what it is. So yep, use these different equations whenever you feel comfortable. Just gonna draw some separation. Okay, so we know a1, we know an, 1 and 27 respectively, and we know n, we calculated that to be 14. So let's stick that in the equation and figure out what we're gonna get. Let's do it in blue, because I like blueberries. Equals, well, n, that's 14 over 2. And then a1, what's a1? That's just 1. An, the last term that we're looking at, is 27. 14 divided by 2, 7. Quick math. 1 plus 27, 28. 7 times 28, according to my, let me pull out my calculator, because my mental math is not the sharpest in the shed, but we found the answer to be 196. Awesome. So the sum of the sequence between 1, 3, 5, 7, all the way up to 27, counting by 2, the sum of all that, 196. And yeah, I actually am pretty confident that's the case. You can check it yourself. You can do 1 plus 2 plus 3 plus 4 plus, 1 plus 3 plus 5 plus 7 plus 9. You can add them all up and you would come to the same result. But use the equation. It's a lot easier. Okay, so they came to the same conclusion, but I guess they, Yep, use the same equation, came to the same conclusion. And we can share the same satisfaction of getting this question all good. Okay, so the above solution is correct.